So dividing polynomials is a totally separate thing. You're going to need long division, and you can use synthetic division in this case. I can show you later. I know that you can use synthetic division because the catch is that what you're dividing by has to be to the first power. The degree has to be 1, or in other words, it has to be linear, right? So I'll show you how to use synthetic division later. But for right now, we can focus on long division. So first things first, we do have to know a little bit of vocab. Now, what is being divided is called the dividend, and what you are dividing by is called the divisor. So for long division, the symbol is going to be this way, right? Synthetic division, which I'll show later, is going to be the flip of that. So you're always going to put the divisor, what you're dividing by, on the outside, and the dividend is always on the inside, right? What's being divided. So I'll write the steps on the right side here. So in my own words, I would say that the very first step is that you're trying to match. What are we trying to match exactly? The variable terms only, okay? And you're looking to match the variable terms with the highest exponent. So in this particular case, we're looking to match x, right? And 2x squared. So you're looking to multiply something, right? So you have to ask yourself, x times what gets me to 2x squared, right? Because we're trying to match them together. So I need a 2. And remember, product rule says that the exponents have to add up together, right? So those exponents are both 1. 1 plus 1 is 2. So after you have matched those terms, now it's time you're going to multiply. You're going to multiply whatever you've matched, so that 2x at the top, by the entire divisor, okay? Now remember, the divisor is a binomial. So please don't forget, you should be always doing the distributive property, right? So we're looking to distribute the 2x to the x and to the -1, right? As I said before, you're multiplying it by the entire divisor. So 2x times x is 2x squared, right? We needed to match them, so that makes sense. And then 2x times -1 is going to give me a -2x. So why are we trying to match? Is because the next step is to subtract, right? And so when you are subtracting the same terms, it cancels out. So that is why we're trying to match in the first place. Now, I usually like to write a minus on the outside because a very common mistake is people forget to subtract the second set of terms. So 2x squared minus itself is 0, right? Now, here's what people technically, there's a subtraction here, right? So people accidentally do -6x minus 2x, which is a -8x, right? That is actually saying -6x minus the -2x. So whenever you have two minuses next to each other, it actually turns into a plus. So you should actually be looking to do -6x plus 2x. That is going to be a -4x. And then you're just going to drop down that +3. And you're just going to rinse and repeat, right? So you're going to do it over and over again until you can't do it anymore. How do we know and how do we know when to stop? I'll talk about that in a second, right? So now we're going to go right back to the top and we're looking to match again. We're looking to match the variable terms only. So we're going to see x times what gets me to -4x. Well, I just need a -4, right? So we matched it. Now we're going to multiply. But again, just be careful. You're always going to be multiplying by the entire divisor. And so you should distribute. So -4 times x is a -4x, and then negative times a negative, so that should be +4, right? So again, then after that, the next step is to subtract. So you're subtracting both terms. So -4x minus -4x is the same thing as -4x plus 4x, so that cancels. That's the whole point of matching. And then be careful, that says 3 minus 4, which is a -1. So you have to ask yourself, can I go one more round here? And the answer is no, because now you're asking yourself, can I multiply or can I match? Can I do x times anything to get to -1? And the answer is no. Okay, and so the rule of thumb is actually when you get one exponent less than the divisor, that's when you know you're done, right? So this is to the first power here, and this is like saying x to the 0 power here. So when you end up getting one less than the exponent, you know you're done. So that's another way you know you're done. So I personally like to circle that last number because that tells me that this is going to be the remainder. Okay, so it's not like in middle school where you just get to write R1, which means remainder 1. So the final answer is going to be, let's see if I can make it in, I don't know, orange. All right, so the final answer is going to be 2x minus 4, but then you're going to add it with the remainder. But here's the catch, you have to put the remainder over the divisor. What do I mean by that? Right, so our final answer is going to be 2x minus 4 plus the remainder, as I said, and you're going to put that remainder over the divisor. Remember, the divisor was x minus 1. Okay, so if you want me to write out everything, right? So the final answer is going to be, the quote unquote answer, right? The result that we get when we do the division is called the quotient, right? So 2x minus 4 is called the quotient. So you're going to do in general now the quotient plus the remainder, what's left over the divisor, right? So that is how we write the final term or the final answer. Now let's go over synthetic division. So as I said, synthetic division, you can only use it when you have a linear divisor. In other words, the highest exponent has to be 1, as I talked about before. This is going to be the opposite or the flip symbol than the long division symbol, and leave a little bit of space because we're going to be writing numbers into 2 rows there. So the very first step is you want to set the divisor, right? So I guess I'll just write the whole thing. You want to set the divisor equal to 0 and then solve for x. Okay, so essentially, this is the root or the x-intercept of the dividend polynomial. So if we do that in this particular case, right, we're going to add 1 to both sides. And so we get x equals 1, right? So in the future, when you learn what's called rational roots theorem, you're going to find that this is the root of the dividend. And so then you would then just plug that into the synthetic division. So it's all connected. But anyway, then what you're going to do is you're going to, this number over here goes always on the outside. So you're just going to copy it. And then what you're going to do, so we're not even doing synthetic division yet. This is all going to be a setup. Okay, so number 2 is then you're going to, very importantly, you're going to take the coefficients of the dividend. Very importantly, it has to be in descending order of the exponents. Okay, so if you didn't write it in a particular order, it's wrong. Okay, it's a very specific order. What do I mean by descending? In other words, you're going to, right? So it's already in descending order. The exponent goes 2, and then it goes 1, and then this is like saying x to the 0. Okay, so you're taking the coefficients, so the number in front of the variables. So be careful, that should be -6 and then +3. Now, just to be super careful, by the way, totally changing the problem, just bear with me for a second. Let's say that this was the dividend. In other words, that -6x was gone. Then super important, right? This is like saying 2x squared plus 0x plus 3. So you would have to put a 0 placeholder. I can't stress that enough. So it does have to be in descending order, okay? So if it like skips an exponent, you do have to put that 0 placeholder or else it's wrong, okay? And then we're still not ready to start. The very last thing you have to do before you actually do synthetic division is you're going to drop the that leading coefficient, that first number, down. All right, so in this particular case, that leading coefficient is 2, so we're going to drop that down. So now we fully set up what we need to do. So here are the steps. It's very similar to long division in that you're going to multiply. You're going to multiply all these numbers down here, always times the divisor, okay? Now, if we notice, by the way, let me back up, there's no variables when you deal with synthetic division, which is really nice. So you don't have to worry about doing like a lot of the common errors in long division. That's why a lot of people like synthetic division. Okay, so you're only working with numbers. So let me actually just write that in the list. Okay, so we're going to actually start the synthetic division. I'm abbreviating here. Here are the actual steps. Okay, so you're going to multiply by the number on the outside. And then instead of subtracting like you're doing in long division, you're actually going to be adding down. Okay, so that is the formula. So 2 times 1 is 2, and then add down, and we should get -4. These numbers should look familiar, but if not, that's fine, right? And then we always multiply by that outside number. So -4 times 1 is -4, and then add down 3 plus -4 is -1. Always circle the last number because that last number is the remainder, which should look familiar, right? We got the -1 remainder in long division. So now once you are done, question is, how do we actually read these numbers on the bottom? So there's a very specific way. So these are actually going to be the coefficients of the answer. Okay, so this is, or should I say, of the final answer. Here's the catch though, that 2, right? So this is the coefficient of the answer, but you always do it the exponent is 1 less than the degree of the dividend. What did I just say? Okay, so in other words, since the degree or the highest exponent of the dividend was 2, so this is going to be to the first power. It's 1 less, and it goes in descending order. So then -4, right? In descending order, this would technically be x to the 0 power, which is 1. So you don't ever need that, right? And then once you are done, you've reached that 0 exponent, right? Like I was talking about here. Then you're going to put that remainder over the divisor, right? So plus the remainder over, remember the divisor was x minus 1. So we do get the same answer. So I'll write down over here, right? So I guess I'll just add a note. So this is to the first power because this is 1 less than the degree, which is the highest exponent of the dividend, right? What you're dividing by. Congrats, you made it. You made it through the whole pretest. I hope this was helpful. So just a reminder, I left a link in the description. I have a whole course on all the prerequisite skills in detail, modules, lessons, homeworks, quizzes, warm-ups, stuff like that. So just as you would for a regular class. So as I said, I'll leave a link in the description onto my website, and I hope I'll see you soon.